So today we're gonna tackle about the logic gates. So there are three logic gates that I'm gonna explain to you guys. So the first logic gate that I will explain to you guys is the NOT gate. So the logic of that gate is that the input will be the negation of the output. So if you put 0 in the input, then its output will be 1 since the input is negated by the NOT gate. Same case to the input of 1. Its output will be 0 since the negation of 1 is 0.
So in our demonstration, we got a specific IC, which is called NOT gate, with a value of 7404. So this IC only got a 1 input that will result into our output depending on its input. If an input is in on state, which comes from the dip switch that provides the voltage, then the output will be an off state. Since the IC's principle is that it negates the state of the inputted value. Same case to the off state input, in which it will result to an on state to the output of the LED.
So our next logic gate is called AND gate. So it takes two inputs usually represented as 0 and 1 and it produces a single output. The output of an AND gate is 1 only when both of its inputs are 1. Otherwise, the output is 0.
So in our next demonstration, we got an IC, which is the AND gate, with a value of 7408. It has specifically two inputs that will determine the output if it is on state or not. If we base it on the word AND, it basically said that the inputs are connected to each other. So if one input is not an on state, then it will output an off state, and vice versa. However, if both inputs are in on state, then its output is an on state to the LED.
So our last logic gate is called OR gate. So OR gate takes two inputs and produces a single output. The output of an OR gate is 1 if at least one of its input is 1. The output is 0 only when both inputs are 0.
So in our last demonstration, which is the OR gate, with a value of 7432 that contain two inputs that will determine the output of the IC. Since it is called OR gate, it basically means that either of the inputs should be in on state. In order for the output to be in on state, example, if one of the input is in on state and the other one is in off state, it will output an on state, and vice versa. However, if both of the inputs are in off state, then the IC will output an off state to the LED.